Okay, AP Calculus AB, Unit 5, Day 6, Office Hours. This was the assignment. They're all odds. You should check them all in the back of the book. Now, some of the answers in the back of the book might not have looked like yours. That doesn't mean yours was wrong. It just might mean that you took a different strategy. So here's a couple other versions of answers for some of the ones that I thought might stand out that yours might be a little different than. So like number 3, number 7, these are some answers that I wrote that I thought would be a good answer, but different than what the back of the book had. So 9B, 17. So check compares you to those, and maybe yours looks more like one of these. But we're going to go over them, and I'll try and explain how to get the answer the book had and how to get some other versions of answers. So there was a little bit of practice just on other, types of derivatives that we have been doing for a while now. So number 1 was y equals the cube root of 2x minus 5, which I would rewrite as parentheses 2x minus 5 to the 1/3 power. That's a power rule. So y prime equals 1/3 2x minus 5. Leave the inside the same. Subtract 1. You're at negative 2/3 times the derivative of what's inside. That's the chain rule. Now let's rewrite it in a nicer form. So without negative exponents, we could write it like this. We could write it like, we could change it back to the cube root, but then it would have a 2x minus 5 squared inside. So something like that. I think the back of the book had this with the negative exponent, which I'm not a huge fan of that. I would rather see something like this. So on your test, 3, y equals parentheses y minus 1 or x minus 1 over x plus 2 to 3 halves. So I think we just got to go with this. Y prime equals, and so the outer derivative is the power rule. Leave the inside the same. Decrease it by 1, and then you got to multiply by the derivative of what's inside, which is going to be a big quotient rule. So it's going to be low d high minus high d low all over low squared. So that's the derivative. Now the only thing left to do is to maybe try and just clean it up. Simplify that. So this would be x plus 2 minus x plus 1, and the x's would cancel, so that's kind of nice. And so we get y prime equals, there's a 3 there, so that'd be a 9. Let's see. Yeah, we could put the nice part first. 9 over 2, x plus 2 squared, x minus 1 over x plus 2 to the 1/2. It doesn't have to be in that order. We could even combine things a little bit. Is square root of x minus 1. We could break this up. We could say 2x plus 2 to the 5 halves. Some different possible answers. We could go with that. I think the book had this one. Number 7, y equals sine 3 over x to the 5 halves. Now I would for sure, I don't know, I think I would treat this as 3x to the negative 1, so I don't have to do a quotient rule. But first thing is going to be power rule, 5 halves. Inside stays the same. Decrease it by 1. Times derivative of what's inside. Derivative of sine is cosine. And then the derivative of what's inside there would be negative 3x to negative 2. So you can do that chain rule all the way. And then for your final answer, I'd clean it up. Negative exponents on the bottom. So we could say negative 15 sine 3 over x to the 3 halves cosine 3 over x all over 2x squared. It's still pretty gross, but I don't know, it's a little better. So that's maybe what I would go with. The book, I think, had that. I mean, you could do this, or you put this in front like that. I mean, that's fine. This is the same thing. So I don't know, it's up to you. Either one of those, I think, is perfectly fine. Get rid of the negative exponents. Okay, let's see. Now, number 9 had several parts. So it said they gave you this x cubed plus xy minus 2x equals 1. And they said part A, differentiate it implicitly. That's a new technique. Part B, solve for y in terms of x and take the derivative essentially explicitly. And C, confirm that the two results are consistent by expressing the derivative in part A as a function of x alone. Okay, so we're kind of doing this problem 2 different ways and then seeing if they actually give us the same answer, even though they'll look different at first. So part A is implicit. So that's that new thing. 3x squared plus the derivative of this would be x times derivative of y would be dy dx plus y times derivative of x would be 1. So that's just that product right there. Minus 2 equals 0. And then we would solve for dy dx, right? So x dy dx, I'd move everything else to the other side. So plus 2 minus y minus 3x squared. And then divide both sides by x. So I get 2 minus y minus 3x squared over x. So that would be the derivative if we did it with that new technique. Now, part B says to solve it for y in terms of x, which is pretty doable. We would want to get the xy term by itself, add the 2x to the other side, subtract x cubed, divide both sides by x. And so then that would be our function, right? And then we're going to go ahead and take the derivative of it like normal. We're going to take it explicitly. So dy dx, we do quotient rule, low d high minus high d low all over low squared. So then we clean it up. So it'd be 2x minus 3x cubed minus 1 minus 2x plus x cubed over x squared. 2x minus 2x, those cancel out. And then we could do negative 2x cubed minus 1 over x squared. So that's the derivative explicitly. Now these look nothing like each other because this one has a bunch of y's. So they said in part C, they say, you know what? Take your answer from part A and write it so it's explicitly all x's. Now what we do is we would use the result from part B and plug it in for the y and then simplify. So we're going to try that. We're going to take our answer from part A and try and get it in terms of purely x. So we're going to take the y and replace it with 1 plus 2x minus x cubed over x. And then everything else stays the same. Okay. So then we're going to try and clean this up. So I would multiply the top and bottom by x to get rid of the complex fractions. So then that'd be 2x minus, and I'm going to distribute this negative minus 1 minus 2x plus x cubed. And then you have a minus 3x squared all over x squared. And then the 2x and minus 2x cancel, and we have, we got to distribute this x we got to distribute the x over here to this guy too, so that should be 3x cubed. So it's going to be negative 2x squared minus 1 over x squared. Does that match the answer we got in part B when it was all in terms of x? It does. So must mean our answers are correct, or at least the same. So that's 9. Got a little practice in doing it a couple different ways. There's another problem later that you'll get that experience on. So these ones say find dy dx by implicit differentiation. Use a new technique, which you should want to do. It's better than explicit. This is a circle one that we did geometrically, but implicit 2x plus 2y to the first times dy dx. It's like chain rule equals 0. Derivative of 100 is 0. So then we're going to solve for dy dx. So 2y dy dx equals negative 2x divided by 2y. And so dy dx equals negative x over y. Now the back of the book, the back of the book had that answer, so that's what I would write. That's a good answer. It's 11. 15 was 1 over y plus 1 over x equals 1. Now, do you really want to do quotient rule? I personally would change this to y to the negative 1 plus x to the negative 1 equals 1, which is the same thing, but now I'm definitely not thinking about quotient rule. I'm just doing simple power rules. Negative 1 times y to the negative 2 dy dx plus negative 1 times x to the negative 2 equals 0. That was not that bad. Now, I might go ahead and rewrite it as 1 over y squared dy dx. Move this guy to the other side and rewrite as a positive exponent. It's going to be plus x to the negative 2, which is 1 over x squared. And so then dy dx equals negative y squared over x squared. So that looks good to me. All right, not too bad. All right, and 17. Last one, sine x squared, y squared equals x. So we're going to take the derivative implicitly. So derivative sine is cosine. Leave the inside the same. Chain rule says take derivative of what's inside. That's going to be product rule, right? So it's going to be x squared times derivative of y squared, which is going to be 2y the first dy dx plus y squared times derivative of x squared is 2x equals derivative of x is 1. So we've done the derivative. Now it's really algebra trying to get this dy dx by itself. So I think there's a couple different ways you could do it. I personally think I would maybe go ahead and distribute this. So you would get 2x squared y cosine x squared y squared dy dx and plus 2x y squared cosine x squared y squared equals 1. So then you want to get this by itself. So you subtract this to the other side, right? Divide both sides by this. So you're going to have a 1 minus 2xy squared cosine x squared y squared divided by 2x squared y cosine x squared y squared. So that seems like a good answer. That is what the answer in the back of the book was. One other option is you could go and distribute this division and break it up into two separate fractions, and things sort of simplify a little bit. So if you did that, you get 1 over 2x squared y cosine x squared y squared minus 2xy squared cosine x squared y squared over 2x squared y cosine x squared y squared. And now you can cancel those. You can cancel a y on the top and bottom. You can cancel an x on the top and bottom. You can cancel the 2's. And you can write the answer. This is 1 over 2x squared y cosine x squared y squared minus, what's left on the top? A y. What's left on the bottom? An x. Just that. Y over x. So, you could do that. Whatever. And if you solve the problem a little differently, you would have got this answer also. So it depends on how you did it. So Anyways, so okay, that's it.